We are live. Good morning, those people in Florida who are driving on those beautiful roads. Here's our theme song today. You know who this is? Foreigner. You know what year this song came out? 1977. I think I was a freshman in college. In Bemidji. And it was 40 below. It was really as cold as ice. And that's me. I never took advice very well. Alrighty, enough of that. Alrighty. So a little bit of review. I'm going to get my picture off of here because we're just really tired of looking at that. Alrighty. This is a little bit of review right here where we're taking the derivative of the natural log. We should know it's 1 over x. So the antiderivative is going to be the natural log. You will want to put absolute value symbols around that, because that protects the natural log from those nasty negative values. And then the antiderivative of something that looks like this, where we have the derivative of g in the numerator and g of x in the denominator, is going to give us the natural log of g of x. Notice it's in absolute value plus c. And so I'm going to show you a couple of methods. And so I gave you that pop quiz for a couple of reasons, in that there were 3 problems that were related to each other. There was this one, and there was this one, and then there was this one. Okay, they look a lot the same, in that they have you're figuring out the antiderivative, and they all have fractions, correct? And so how are you supposed to figure out what to do where? And what I'm going to do is kind of give you some hints, okay? And what you'll see me do every time I come to an expression in which I have a fraction, I will take that denominator, I'll put it in parentheses, and I'll raise it to a power. So that has a degree of 1. Now the degree of 1, if I would write it so it's not in fractional form, that would have a degree of a negative 1, correct? And if I add 1 to a negative 1, I get 0, which has no reciprocal. So when I write 1, I automatically think that I'm going to have natural log as my answer. So you'll see me take in that denominator, put in parentheses, and write what exponent it is. If it's a 1, I use natural log. If it is not a 1, I reverse the power rule. That's my hint to look at. So I'm going to rewrite it again. And I'm going to do this particular problem 2 different ways. And so I'm thinking my answer is going to be natural log. And so I look at whatever this quantity is, and I take its derivative, and Nikita, what do I get as its derivative?
2x plus 2.
2x plus 2. And I immediately go up here, and I'm looking for 2x plus 2. Is it 2x plus 2? No. Can I do some arithmetic to make it 2x plus 2? Yeah, I could do what?
You can multiply the quantity by 2.
I could multiply the quantity by 2, which I can do anytime I want, as long as I multiply by 1/2 out here. Is everybody okay with that? So what I'm going to have is I'm going to have the natural log, the absolute value of x squared plus 2x, 1/2 plus c. The book or the AP exam may give you this as an answer, and you got to be okay where that square root came from. And are you? Right, because that 1/2 is going to be a power, so this thing will be to the 1/2 power, correct? And that's how I write x squared plus 2x to the 1/2 power is the square root. Are we okay with that? All right, I'm going to do u substitution. If I do u substitution, I'm going to do it right over here in this little space. I always let u be the denominator. That's what den period means. And so it's going to be x squared plus 2x. I'm going to take the derivative. Du dx is going to be 2x plus 2. That means du is going to be 2x plus 2 times dx. I look here, I don't have a 2x plus 2, I have an x plus 1. So I'm going to factor out a 2 and get x plus 1 dx. So 1/2 du will replace x plus 1 dx. I'll say that again. 1/2 du is a replacement for x plus 1 dx. So what my integral becomes is 1 over u, 1/2 du. So there's the x plus 1 dx. There's 1 over x squared plus 2x. So this is the same as 1/2 times the integral of 1 over u du. That's natural log, so I have 1/2 natural log of u plus c. I write that down because I don't want to forget about it. So then I have 1/2 natural log of x squared plus 2x plus c. So that's how you can use it using u substitution. Okay? All right, Aaron, I'm going to rewrite this here. I'm going to write 1 over 3x plus 2. Hannah, can you see that okay? Yes? Okay. And I see a fraction. And then I come down to the denominator. I put parentheses around it. I'm going to put a 1 here. That means it's going to be natural log. I'm pretty confident. I'm going to multiply this by what? 3. So what needs to be out front? 1/3. And so can you tell me what the answer is going to be? That is perfect. And if you want to write the cube root, you can, you don't have to. Okay, I just put the square root here because you might see that as an answer like in the back of the book or on an AP exam. Okay. We'll do a process later on when we get to chapter 6 where you'll see me write the square root. And you'll see why, but you don't have to do it right at this moment. You have to understand why I can do the square root. Does everybody understand the difference? But it's not a necessity. Ellie, 1977, I came across this problem. It was a homework assignment. 25 minutes. Could not figure it out. I was doing trig like crazy because I was a trig expert. Could not come up with the answer. So I called Jackie Rasmussen, who was in my group. And she said this, Kruger, come down here, write tangent x, put parentheses around it, put 1 to the exponent, and write dx. I started laughing. I go, I am a complete idiot. And she said, yeah, I know. And she was really, really smart. She helped me get through my freshman year of calculus when I was in college. And then she dropped out of school and became a nurse, which, you know, is not an easy job either. So why is that helpful?
Because it tells you the natural log.
Why? How do you know that?
Because the exponent is 1.
Yeah, but is that the derivative of tangent? Yeah, it is. Okay, right? You need to know the derivative of sine. You need to know the derivative of cosine. You need to know the derivative of tangent, which is secant squared. Okay? So what's the answer?
Natural log, the absolute value of tangent x plus c.
Perfect. That's it. And in some sense, it's easier, isn't it? It's a little bit less work. little less chance. Is it okay? Slide it this way.
There.
Is that better? Okay. Megan, I'm going to take this. I'm going to write 1 over 4x minus 1, parentheses. I'm going to put my 1 there, dx. Right? It might be a 2. If there was a 2 there, Megan, I'd be doing it differently. I'd reverse the power rule. But it's not. It's 1. For everything else, I reverse the power rule. So, Megan, what do I need to do here?
Multiply the top by 4.
Okay, which is easy to do.
And then put 1/4 on the outside.
Okay, and so what's your answer?
1/4 natural log of 4x minus 1 at the absolute value plus c.
Perfect. Hannah, you're not going to do number 5. Brady is. So he can get all fired up for it. Okay? I'm going to ask you this question right here. What's the antiderivative of cosine? Now, there are some things that trip me up in calculus even to this day. And it's the negative and positive of this, okay? So I always have to ask myself, the derivative of what gives me cosine? Sometimes that helps. What are you going to tell me the answer is?
Negative sin x.
No, it's not.
Sin x. C.
Let's see. And see, by you doing that, you helped out Cullen immensely. Brady, not so much, but Cullen a lot. Okay? Because Cullen's question is, what's the antiderivative of sine of x?
Cosine?
No.
Negative cosine.
Negative cosine x plus c. Okay? And the problem is, folks, these kind of questions are on the AP exam of multiple choice. Both negative sine x plus c and cosine x plus c are part of your choices. So you got to know. You got to know the derivative of sine. You got to know the derivative of cosine. You have to know the derivative of tangent. And when I took an exam that was on the antiderivative, I wrote down the derivatives. So I knew that if I go in the opposite direction, I could figure it out. Okay? So we also, the derivative of tangent is secant squared, which is weird. It's weirder than the other two. This one's weird too. And you have no idea. Okay? Which you shouldn't. Okay? So I'll give you a little hint. I bet you know this. That's not a shocker to you, is it? And then I'm going to do this. Okay, you know it's natural log. Of what? Okay, now, is the derivative of cosine sine? You know what? Just as you said that, she coughed.
Sorry.
So you might have said it right. Okay, it's negative, isn't it? So I have to have a negative here. Okay, so you're almost correct with the answer you gave me before, but it should be what? Negative natural log of cosine x plus c, which is the same as the natural log of the cosine of x to the negative 1 power plus c. Correct? Correct? So this is correct. This is correct. This is equal to the natural log of 1 over cosine plus c. This is correct. So what's another answer I can say? What's the reciprocal of cosine? So this could be an answer, or this could be an answer. Okay, now, to be honest with you, I'm good at remembering what the antiderivative of cosine is. It's sine. I'm semi-good at the antiderivative of sine. It's negative cosine. I'm really poopy when it comes to the antiderivative of tangent, but I can do that every single time. And then I can put the negatives, and then I can come up with that. You understand what I mean? That you just did a proof, by the way, Brady. That's a proof that could be on Wednesday's quiz. Or it could be this proof, Hillary. I want you to prove that this is this.
That's equal to cosine and sine.
You want me to do anything special? You want me to do this?
The negative, because the antiderivative of sine.
No, the derivative of sine is?
Oh, cosine. So then okay.
Well, I don't know. Are we?
Natural log of absolute value of sine.
You're done. That's the proof. Remember when you guys walked in this class, you hated proof so bad? God, I hate them. When I go to hell, I'll be doing geometry proofs. I know. I love geometry proofs. You know why you hate them? You didn't work in a welding shop. You know what I learned in a welding shop? That when you measure the diagonals of a four-sided figure and those diagonals are the same, it's square. The corners are square. And then when I got to be in 10th grade, I got to prove why that was true. I didn't like them at first, but I grew to love them. Alrighty. Whose is this? Allie, would you like to know what that graph looks like?
Sure.
Okay, I'm going to go to my phone. And I got a little thing on here called Desmos. Desmos, where's Desmos? So there's Desmos. And it's parentheses 2x parentheses divided by, notice how I made a fraction right away. That's kind of cool. X squared, is it plus 1?
Yeah.
Ooh, that's what it looks like. Oops. Oh, that was dumb. Why did I do that? User error. That's why old people should not ever have a phone. You know, somebody makes a good comment and then I don't get to hear it very well.
That's probably what they were doing at the stoplight, was graphing.
Alrighty. I got picked up for one time doing calculus, but the person did. So it's from where the x-axis to here, correct? That's what the graph looks like.
Okay.
Okay. BC Calc, you could see that it goes on forever and gets closer and closer to 0. Do you see that? But it can't ever equal 0.
Right.
Okay. We actually compute the area of that as it goes to infinity. We're doing it on Thursday. You could watch it live or delayed if you want, in front of a live audience like I am right now. That's how we should start. Taped in front of a live audience. Alrighty, so tell me what to do here.
We take the derivative.
No, it's area. What's the purpose of derivative, by the way?
On slope.
Bingo. Of a slope of a what?
Line.
What kind of line? Tangent line, correct? Okay, but not figuring out area, correct? How do I figure out the area? I have to take
X times
No, okay. We do it based on, we're not going to limit either. See, sometimes they give you the wrong answer when they whisper.
Okay.
We have two things. We have derivative and we have integral, right? So derivative is finding the slope of a tangent line, correct? Or the instantaneous rate, right? And the purpose of an integral is to find what? Area. If it's a what kind of integral? Definite integral, okay? So we're going to integrate, okay? Yep, that's why we go over it, okay? X squared plus 1 dx. Now, what's my A and my B? Because a definite integral has a boot and hats, right? It has numbers there.
So the A would be 0 and B would be 2.
Correct. Okay? Purpose is figure out the area underneath the curve. Okay? That's why you come to class. Okay? When you learn something new, you're going to be iffy on it. Okay? And what's nice, come May, you won't be iffy. Okay? Now, notice what I do here. So I look at this, is the derivative of this, this? And it's an exponent of 1, correct?
So it would be like the natural
Of what?
x squared plus 1.
X squared plus 1.
Plus c.
No plus c because it's a definite integral from 0 to 2, correct? So what gets put in there first?
2.
Okay, 2 squared
4.
plus 1. See, that's the easy part of calculus, right?
Yeah.
Minus, correct? The natural log, I put 0 in there. What do I get? 1. What is the natural? No, because this is a calculator-free question. Okay? What's the natural log of 1? So natural log of 1 means the base is e, correct?
Yeah.
And in any log, you're trying to find an exponent, correct?
Yeah.
So e to what power is 1?
0.
So that's your answer. If it was calculator, you could put that in there and give me correct to 3 decimal points. But more than likely, it's calculator free.
Oh yeah.
Oh yeah, what?
You could just like do the log where like it's ln of 5 divided by, so like it's ln of 5 divided by 1.
Yeah. That's a good way to think about it. That's very good. Yeah, you could have done this. You could say, hey, it's ln of 5 divided by 1 and come up with 5. Yeah, good idea. Is that yours? Or yeah, good thinking. Good thinking. Alrighty, we're to you. All right. So, what's the degree of this?
2.
What's the degree of this?
1.
2. They both have the same degree, right? So, if the denominator, the degree of, not denominator, I'm sorry, numerator, is greater than or equal to degree of that's supposed to be an F, denominator, you have to do long division. So you get to do long division because they're tied. Okay? So I got x squared plus 1. And you're going to divide that into x squared plus x plus 1. And when I say long division to a lot of people, they get really scared. But the long division in calculus is important, but it's not complicated. It's not like you get a whole bunch of terms. So this is how I'm going to start. I look at this first term, I look at this first term. What do I multiply x squared by to make it x squared? 1. So there's a 1 there. So this is going to be an x squared, and this is going to be the plus 1. Does that make sense to you? And then what I do, because I have an issue with subtraction, I make them the opposite and add. And I get x. This is called a remainder. Do you guys remember that term? This is called the divisor. So my integral is going to become this. 1 plus x over x squared plus 1 dx. So this is kind of like a mixed number. Does that make sense? So when I have this, this is what I start doing now. Is when I have sums or subtractions, I break them up into separate integrals because the methods that you're going to do the antiderivative are different. I'll show you what I mean. So I'm going to write this as the integral of 1 dx plus the integral of x over x squared plus 1 dx. Okay, Abby? And I know I get points from Kruger for if I get this far, I got something, correct? So I do the easy one first. Well, I hope it's the easy one. What's the antiderivative of 1? X. So this is x plus. Okay? Now this is going to be done differently. 1 because it's a fraction, right, folks? So I'm going to put parentheses around it, and I'm going to say, oh, the exponent of that is 1. So I'm thinking natural log. And I look here, what is its derivative? 2x. So I put a 2 there. And then I'm going to write what out front? 1/2. So this is done totally different than this, isn't it? So now I'm going to come over here, and I'm going to finish this baby up. Or you are. What's it going to be?
1/2 natural log with the absolute value of x squared plus 1 plus c.
Plus c. And you're done. Now just realize they might have the square root of x squared plus 1, right? Everybody okay with that? Alrighty. Maureen, you've got a tough one. Okay? This is also calculator free. First of all, it says average value of a function. And just like with Allie, there's a lot of stuff to remember, correct? And so she had to remember, and it is hard. You know, and I talk about driving, when I first learned to drive, putting it in drive when I'm supposed to back up and going through the garage door twice. Okay? Because I learned to drive. I was nervous. And I didn't do, and I know when you guys take a test, you get nervous and you go, God, I should never have made that mistake. I should never have forgotten all my plus C's on a pop quiz. Okay? It's better than a 0 out of 10 because I did exactly the same thing. Okay? Okay? So, one of the things you have to remember is average value of a function. How do we figure it out?
You have the definite integral
From?
0 to...
Yeah, let's just do the general one and then we'll come over here.
Oh, 0.
Well, from A
Oh, a to b.
of f of x dx, and then what do I do on the bottom?
b minus a.
B minus a, okay? That's the tough thing to remember. So over here, you're going to integrate from 0 to pi over 4 of the tangent of x dx, and you're going to divide it by pi over 4 minus 0, right? Or just pi over 4.
Yeah.
Now, luckily for us, Brady did the work already. And we could just look in example 5 and know what the antiderivative of tangent is, correct? What is it?
The natural log of c, absolute secant.
Well, I'm going to use cosine.
Okay.
Are you okay with that?
Yep, that's fine.
It's the easier one. Secant, I like cosine a lot better than I like secant. Secant requires work. From 0 to pi over 4, correct? Divided by pi over 4. You're okay with that so far?
Yeah.
So I'm going to have a negative natural log of the cosine of pi over 4 minus the negative natural log of the cosine of 0 divided by that. I'm sorry about drawing my line through my 4. That's kind of messy on me. Of pi over 4. Okay? So, this is the part that they expect that you know. So I'm going to have 4 over pi. Because when I divide by a fraction, I multiply by its reciprocal. Would you agree? Times the negative natural log of what? What is the cosine of pi over 4? They expect you to know that.
Is that
No.
square root of 3 over 2?
No.
Oh, 3 over 2 over 2.
Yeah.
Square root of 2 over 2.
Okay? Cosine of 0. Natural log of 1. 0. So I got plus 0 here, correct? So your answer is negative 4 over pi natural log a square root of 2 over 2.
What happened to the negative?
It's right here.
Oh.
I didn't make it big enough. Okay. Last problem, almost. Okay. Kyle, how would you do this one?
I probably just foil it.
You would foil it?
Yeah.
Okay. Foil it for me.
Okay, x to the 4th plus 2x squared plus 6,
Plus 1
yeah, plus 1 and
times
multiply by
6x. Okay, and then what do you get?
6x to the 5th plus 12x squared plus 6x.
And then you'd have what as an answer?
X to the 6th.
Wouldn't it be 12x cubed?
Oh, it is greater than
And then I'd have 4x to the 3rd. And then 3x squared. Plus
Right?
Wait,
So
wasn't
that
it
makes
when you,
sense.
after you foil it the first time, it's 2x squared?
Yeah.
So then that'd make it 12x
Oh,
over there.
Maybe 12 before it is,
Okay. I wouldn't do it that way. Holland, would you have done it that way?
Yeah.
Anybody do it a different way? I would have done this. Isn't 6x this, the 6x? Does everybody see that? Could I do what? Scoot it somehow? Okay. But either way is fine, as long as you don't make this mistake. Okay, Holland?
Yeah.
Okay, Holland, I got a question for you. You know what that is? What?
Wait, what?
This.
The line?
Well, it's not a line. Yeah, it's squiggly. It's a curve. Okay? Okay? Here's my question. You ready?
Yeah.
Remember, Allie brought up a good thing. There's so many things I'm going to forget, I think I'm going to die. Okay? That's not what she said, but that's how I felt. Okay? That's how I felt she felt. Am I right? Yeah. I understand that. It's not like I haven't been there. Okay? Do you know how to do that? Can you do any part of it at all?
Well, you like put y over dx squared.
What's this going to be? I'm asking you to take the derivative with respect to x, correct? What's the derivative of that?
Wait, what was your question?
What's the derivative of x squared?
Oh, 2x.
Okay? We've got something, right?
Yeah.
Okay? For a math problem, I think the hardest part as a teacher is when somebody says, I don't even know where to start, right? It is, okay, so I say, okay, I always say, can you write your name? I mean, when I went to college and I took a test in math, all of a sudden, and when people have math anxiety, all of a sudden I had for the very first time math anxiety, and I looked at the problem, I said, I can't do this. And then I was really big trouble because I realized I want to be a math teacher and I can't take a math test. This is not good. So what I did is I had to figure out a way that I could get through that. Here's my, all right, I'm going to write my name down. I know I can write my name. Okay? And then I said, all right, what's the next thing? I can take the derivative of x squared. And hopefully I can calm myself down and bring back and remember a few things. Can you take the derivative of that?
So it would be 9y squared dy dx.
Ah, you very good. And what about this? 0. So you successfully took 3 derivatives, correct? What are you going to do next? Solve. So what's dy dx?
It would be negative 2x over 9y squared.
You're done, right? Everybody got that? All right. Gavin, I'm giving you something ready for Thursday. Hence, the curvy line, or the curve, correct? Has nothing to do with what I talked about 5-1 or 5-2. This is 5-4. Okay? We're going to take the derivative of e the x. Okay? You ready? I'm first going to tell you, this, by the way, folks, is a proof. I'm going to say e of the x equals y. Okay? I'm going to take the natural log of both sides. You've seen people do that before, right? I'm going to ignore this side. I'm only going to concentrate on this side. Are you okay with this?
Yes.
Are you okay with that?
Yes.
The ln of e is 1, right?
Yeah.
Yes, sir.
Why not just, when you have e to the x equals y, why not just make it into the log form right there?
I could have. I could have. I could have skipped all the way and went right to there. You are exactly correct. Okay? Gavin, we're going to take the derivative of this. What's the derivative of x?
1.
What's the derivative of the natural log of y? Well, it's going to be a fraction, correct? What's on the bottom? What's the derivative of y? Now you got to think of what Holland did.
dy over dx.
It's dy over dx. So are you okay that y equals dy over dx?
Yes.
What's y?
Dx.
Say it again.
E to the x.
In summary, what does that mean? What's the derivative of e to the x?
It's a derivative of y.
Say it again.
It's dy over dx.
Right. What's the derivative of e to the x? What is dy over dx?
The derivative of y.
Correct. And which is, what is our answer? Does anybody know what the derivative of e to the x is? Kyle.
E to the x.
It's e to the x.
Oh, yeah.
I'm taking the derivative of e to the x. I said e to the x equals y. I get to here, I take the derivative, and I come back to y, correct? Which is e to the x. So it's like I did nothing at all, correct?
Why is that?
Because it's the only function that is its own derivative. The derivative of e to the x is equal to e to the x. You understand why I only take one day to take this? What's the antiderivative of e to the x? Almost. Plus c.
This is
Yes.
so E is a constant, right?
2.718.
So why can't you just do any constant to the x power and have it directly equal?
Okay. Would you agree with that? This is a what? A constant, isn't it? What's the derivative of this? Well, according to Gavin, it's 1 over y with dy dx on top. Correct? What's the derivative of this?
Nothing.
It is something.
Just element 2.
Just the ln of 2. Right? If it was x times 2, it would be 2, correct? So that means dy dx is equal to the ln of 2 times y, correct? But what's y? What am I asking you here? The second derivative. What do you think the second derivative is? Guess what the third derivative is?
I don't think we need to do that one.
Do you think you know the answer?
For God's sake.
That's Thursday, Friday. You don't need to know that for Wednesday.